running clubs drove a lot of our decisions.
A lot goes into making sure the components are put in the right place.
Customers have wanted that flashlight in the 970, so that was a must-have.
Trying to find a way to have all of the features, but not take so much processing power.
What will be popular when the watch actually hits the market?
When you look at the watch, it screams, I'm a runner.
If you're a runner, you probably wear one of these, a GPS watch. I've been lucky enough to be invited to Garmin's headquarters in Kansas City in the US to find out exactly what goes into taking one of these watches from just being an idea in someone's head, maybe a drawing on a piece of paper, all the way through to being made and launched and then available for you to buy. So I've met some incredible people. Let's go and find out how it all happens.
I was there for a secret launch. So secret, in fact. I didn't even know what it was until the day I stepped onto campus. The brand new Forerunner 570 and 970. But before we talk watches, let's rewind. Garmin actually started in aviation. Founded by Gary and Min, yep, that's where the name comes from. They build the cockpit tech for thousands of small aircraft worldwide. I got to try out their giant flight simulator. And even took to the skies in a real plane, not at the controls this time, luckily, because it was wildly windy.
What? So glad to be back on the ground. Thank you so much for that.
From aviation to automotive, marine to golf, and of course running, think Formula One style research and development that filters right down onto your wrist. There's a huge campus, design studios in Kansas City, Taipei, and Portland, Oregon, thousands of employees, but how does it all come together to create your running watch? It starts with the product manager. They map out what the watch needs to do, who it's for, and the features it will include. How long does it take, roughly, to go from, we're going to make this watch, this is a thing that we're going to do, to then the launch and it being available to buy?
It is a long process. You can think of it in years instead of months. The more complex the products, and the more teams go into it, and the more builds and testing that we need to do to bring it to market. We definitely have gotten a lot of feedback that customers have wanted that flashlight in the 970. So from like a hardware perspective, that was a must-have in that product. We really wanted something that, when you look at the watch, it screams, I'm a runner.
From there, the brief lands with the industrial designers, the big thinkers who work hand in hand with electrical engineers who look at the electrical components within the watch, and the mechanical engineers responsible for the case, the bezel, the buttons, and external hardware.
I mainly focus on the electrical design engineering aspects of designing Forerunner watches, so like the circuit boards and antennas and batteries and displays. The main thing at the front end of the project is designing them, doing schematics and circuit board layout.
The designers dream it up.
We were given more of a exploration goal, so we looked a little bit more broadly and sketched a little bit looser than we typically would.
The engineers make sure it can actually be built.
So you have to figure out all the different electrical components that need to go into your design and how you're going to fit them in the package, especially like the 42 millimeter size products. Trying to fit all of those on the circuit board can be a challenge.
They begin with user research, digging into feedback from previous models and talking to runners about what they want to see next.
So we've got usually a host main processor, and then it will have some memory attached to it, and then we'll have usually a GPS receiver. Then we can have other processors that do like the sensor functions for like the
so like for the heart rate
and for the barometer and accelerometer and magnetometer and gyroscope. And then also for our products that have NFC, we have an NFC chip. And then we'll have usually a 2.4 gigahertz radio to do your Wi-Fi, your ANT, your BLE, and Bluetooth.
Then comes inspiration. They visit running stores, analyze trends, work with the CMF team, that's color, materials, and finish, to explore new textures, colorways, and tones.
Especially when you're looking at kind of the boom of running clubs across the globe, and that kind of energy drove a lot of our decisions in terms of color and pop-in energy and all that stuff.
So we start super rough with this project specifically, and then we kind of refine as we go.
Sketches go from loose hand drawings to precise CAD files, that's computer-aided design, which then feed into CNC machines or 3D printers, producing prototypes in under 24 hours, laying down layers of resin, which is cured as it goes.
Garmin really has a strength and it's passionate people, so a lot of our user research was just Garmin employees that we brought in who are really dedicated to running and the sport and kind of gave us a lot of really good insight.
Malika from the team flew to Taiwan just to assess translucent material combinations in person, all inspired by the CMF team's future trends research.
After that, we do some testing on it to make sure that after UV exposure and all that, the color is still acceptable to us.
They'll also look at bringing some of those finishes to life in the plating lab, where they can electroplate metal parts to apply different colors like black, nickel, or gold. Wires need to be micro-welded onto the bezels to deliver the current. Or in the blast room, where metal parts are blasted to give a satin look. Even the watch straps go through endless iterations.
These are all the 3D prints. So we'll go back and forth between CAD and the prints. We can generally get a turnaround in about a day. So we'll work on a few different iterations throughout the day. We'll send them to print. And then in the morning, we can take a look at all these. We can put bands on them, try them on different people.
Wear a kind of
Exactly. Yeah. So sometimes we'll take these home, we'll wear them for a day, we'll see how they feel. We're trying to find just the perfect level of translucency. So it's like Goldilocks, you know?
Whilst all this is happening, the engineers are solving how to squeeze things like 4+ antennas or 10+ processors onto a circuit board just a few centimeters wide.
And it's not just about putting everything on the board. If you just throw all the components on the board and make them fit, that doesn't mean it will actually work. There's so much that goes into putting the parts in the right place. So for example, if you have something that's gonna heat up and you have that near your GPS processor, that might actually affect your GPS. Or if you put your power supply next to your GPS, that can also affect the quality of the GPS. So a lot goes into making sure the components are put in the right place. I know battery life is really important for our customers, and but we also want to add a lot of features. Sometimes those features take a lot of current, which drains the battery. And so a lot of our time is spent trying to find a way to have all of the features, but not take so much processing power that it's constantly draining the battery down. So we spend a lot of our time measuring the loads going to different processors and during different features to figure out like where is it going and how can we optimize it to improve the battery life.
Then comes testing. Garmin's own staff, many of them strong runners, put the prototypes through serious field testing.
And then you're a 225 marathoner, is that right?
I am, yeah.
You've got 2 watches
Back in my days.
Yeah, and you've got 2 watches on right now. So you're out there not just testing the kind of a theory in the lab. You're like, you're out there putting the watches through hundreds of miles.
For sure, yeah. Actually, I didn't start running until I started working in the fitness department about 15 years ago. And I was just like, maybe I should start testing these out. And I just found a real passion for running and marathon running specifically.
But it's not just humans. In a secret test lab, where we couldn't film, machines drop, crush, stretch, and freeze the watches from plus 85 degrees C to minus 40 degrees C in 30 seconds. Thousands of button presses, sharp edge drops, brutal simulations. All of it, the research, sketches, electronics, finishes, and thousands of miles of testing goes into the making of your running watch. So the watch has gone into production, but now you want to buy it. You hit order, and then this place springs into action. There's almost 750,000 square feet of warehouse space here in Kansas for US shipping. With robots, staff, conveyor belts, and shelving piled high, aiming to average under 5 hours from you hitting buy to it being shipped out.
That's it. It was a whirlwind. I didn't have very long, but I've met some incredible people and learned loads of amazing things. And I'm a big geek about this sort of stuff. I used to be an engineer, or wanted to be an engineer. So it's fascinating for me. But I'd love to know what you thought, whether that was interesting, or whether you've got any other questions. Let us know in the comments. And if you like what we do at the Running Channel, don't forget to hit subscribe, maybe give this video a like. And we'll see you next time.